Hey everybody, if you watched the previous video, we talked about vertical shifts and how to move our graphs up and down, whether that was the parabola or the absolute value V-shape and things like that. Today we're talking about horizontal shifts going left and right on the x-axis, and you're going to notice, like in both of these equations here, that there's a number in with the x, and that means it's going to move it in that x direction. It's going to move it left or right. We're just going to go ahead and go old school to start this off with the blue one, and we're simply going to make a table to plug some numbers in. You can always do this. Just simply pick some numbers, plug them in, and see how it goes. I like on my tables to always have a couple negative values and a couple positive, but after you start going, you might realize that you need to change that up. So in the blue equation, I could start by putting in the 0. Let's start with an easy number. 0 plus 4 is 4. The absolute value is 4. So 0, 1, 2, 3, 4, and we got a point on the graph. If I plug in positive 1, 1 plus 4 is 5. The absolute value of that is 5. So 1, 5. So already I'm seeing I may not have picked the best numbers, but it's all good. We're just trying to get a start there. Okay? I'm not even going to go to 2 because that's going to be off the graph, so I'm not worried about that. Let's go ahead and check out this negative 1 that we plug in. If we plug in negative 1 plus 4, that's 3. The absolute value stays at 3. Okay? Negative 2, we plug in negative 2. Negative 2 plus 4 is 2. The absolute value is still at 2. So I've got the linear part of my absolute value, but I don't know where the vertex is at the moment. I don't know when it goes back. So I'm going to have to, kind of adjust my table and plug in some numbers, I think a little bit more to the negative side. I plug in a negative 3 into that equation. Negative 3 plus 4 is 1. The absolute value of that is still 1. So negative 3, 1. All right. If I plug in negative 4 plus 4 is 0. The absolute value of that is 0. Okay, I still don't see the V shape. Negative 5. If I plug in negative 5 plus 4, that's negative 1. The absolute value turns it to a positive. Ooh, so we just noticed the absolute value actually took a negative number and turned it into a positive. So now I can see I got that V shape, and here's the graph. Cool, so how did this shift? We're doing horizontal shifts. Notice it's an x plus 4. You may have thought that it was going to move 4 in the x direction. It actually went negative 4 in the x direction. So interesting. Let's think about when we plugged in negative 4, that led us to 0, and that ended up being the vertex point of our absolute value. So almost trying to get to 0, like I love the phrase, think 0. I use it for all of Algebra 2. If you have any group, absolute value, parentheses, a square root symbol, try to get that to 0, and it's going to tell you a key point. So if we look at this blue equation, x plus 4, how do we get that to 0? Negative 4, plugging it in, would get us to 0, and boom, that is our key point. There's the vertex. So that is going to go ahead and shift that 4 to the left. Okay? So we obviously don't want to make a table every single time, but now maybe we're starting to make some connections and see if we can understand a few things about it. Actually, I'll just go ahead and leave that up there, and I'll just change to red. Cool, for red, let's go ahead and plug in a couple values. Let's think about how to get to 0 there. If we plugged in a positive 4, 4 minus 4 is 0. So 1, 2, 3, 4. I plugged in a 4. I got 0. So I'm not doing the normal table. I just went ahead and plugged in 4, and I got 0. Let's go ahead and plug in the point after it, 5. 5 minus 4 is 1. The absolute value is 1. Okay. Let's plug in the point before it. 3. 3 minus 4 is negative 1. The absolute value flips it to a positive 1. 3, 1. Notice that we found that key point at that 4, 0 simply by thinking about 0, thinking about how to group that, get that group to 0. So if it was x minus 4, I needed to plug in a positive 4. Positive 4 led us to 0. That was the vertex. Notice I don't need a bunch of other points. I can already see my absolute value V shape that is happening there. So interesting. It was a positive 4 in with the x. It actually went 4 to the left to negative 4. And x minus 4 actually went 4 to the right to that positive 4 value on the graph. Okay, so a little bit of opposite or switching. So horizontal shifts, maybe you're making a note and looking at. Let's go ahead and take a look at some other graphs. We've got a quadratic here, a parabola in purple. We've got x minus 1 squared. Let's think about some key points that would help us out. What is going to get us to 0? If we plug in 1, 1 minus 1 is 0. 0 squared is 0. So a key point is 1, 0. Let's go ahead and plug in 2. 2 minus 1 is 1. 1 squared is 1. Let's go ahead and plug in the point before it, 0. 0 minus 1 is negative 1. Negative 1 squared is 1. Hey, it looks like the absolute value v shape, but remember that we have a squared here, so it should be a parabola. Maybe I need to go another point. What happens when I plug in 3? 3 minus 1 is 2. 2 squared is 4. So 1, 2, 3. 1, 2, 3, 4. Now we can see that it curves and it is not that absolute value straight line anymore. So we're getting our parabola that is just like that. Cool, on our green one, we're gonna go ahead and take a look at the same thing. X plus 1, I'm gonna go ahead and make a quick table. Try to think about how to get to 0. So the x there would be negative 1. If you think about how to get to 0, negative 1, plugging it in, will get you to 0. 0 squared is 0. So I'm going to go ahead and plot that key point. Notice that a plus 1 on the graph, we think x with a positive 1 will go to the right, but we almost got to like solve for x, and that just moved us to the left, kind of opposite maybe of what we thought, right? If we plug in a 0, what are we getting? 0 plus 1 is 1. 1 squared is 1. If we plug in the point before it, negative 2 plus 1 is negative 1. Negative 1 squared is a positive 1. We got some key points, but remember this is not the absolute value. It's going to be a curved quadratic. Think about the last one in blue, and then we'll finish up the video. What is a key point that could get you to 0? That would be negative 2. If you plug in negative 2, plus 2 is 0. What's the square root of 0? 0. If you plug in some other points, you're going to find that you basically just get your square root graph from there. So really, if I can just get that first key point by thinking how to get to 0, think 0. So if I go, the x needs to be negative 2, you go plot that negative 2, that is your 0, it is your key point. It's actually to the left, even though, again, you may have thought that the x plus 2 would go positive 2. We almost got to solve for the x. Think about how to get to 0. Then if you know the shapes of your graphs, you just continue the shape of your graph, and it's pretty easy. But yeah, big idea for these horizontal shifts is that they're kind of opposite. You really are setting it equal to 0 or thinking about how to get to 0 before you are graphing each of those. Or you can always go old school and do the XY table just like I did on all of the other ones.